Hello and welcome to the GCSE Science Tutor. Today we're looking at Lesson 7, Development of the Periodic Table. Now in a previous lesson we looked at the history of the atom and how the model of the atom changed over time with different technological and scientific advancements. So see if you can match the model of the atom with the key person that discovered it. Pause the video now and I'll go through the answers on the next slide. So A was the Thomson's model, or the plum pudding model, which had a ball of positive charge with embedded electrons. B was just a round sphere, and we call that Dalton's model. C was the Rutherford nuclear model, which was proposed after the alpha scattering experiment. D is Chadwick's model, where he discovered the neutrons in the nucleus. And finally, we also had the Bohr model, where he proposed that electrons were not all over the atom, but in discrete, individually fixed shells. We have used the periodic table in many lessons already. The key features of the periodic table include the fact that it is arranged by atomic number. That is the bottom number of the periodic table. So, for example, we can see that hydrogen has an atomic number of 1, followed by helium with an atomic number 2, 3, 4, and we increase in atomic number as we go across the periodic table. You may think that the mass number is also increasing as we progress through the periodic table. However, this is not always the case. For example, take the bottom elements here. You will see that they are in fact not in increasing mass number. The same with the two elements here actually have the same mass number. And also argon has a mass number of 40, whereas the next element, potassium, actually decreases in mass number of 39. So it's important to remember that the periodic table is arranged by atomic number. We also know that the periodic table is arranged in groups. These are the columns of the periodic table, and there are 8, 1 through to 0. Groups of the periodic table have similar chemical properties. That means that they react in the same way. The periodic table is also arranged in periods, and they are the horizontal rows. Again, it is important to note that hydrogen and helium make up period 1. It is often confused by students that lithium and beryllium start period 1, but this is not the case. Lithium and beryllium start period 2, and we can number down like so. The modern day periodic table can also be divided into metals and non-metals by using the staircase divide under boron, like so. We find our non-metals on the right and metals on the left. The periodic table hasn't always looked this way. Early periodic tables were in fact arranged by atomic weight, which we now know as atomic mass. Many elements hadn't been discovered, the periodic table was incomplete, and many elements were not grouped by their properties. For example, if you take the periodic table down here on the right, you will see that in fact iodine was placed in the same group as cesium. Iodine is a non-metal and cesium is a metal, and they behave very, very differently. Early periodic tables also mixed together metals and non-metals, again given by the example of iodine and cesium. So why did ordering by atomic weight or mass not work? Well, again, let's go back to the example of argon and potassium. If we swapped potassium and argon round, based on their order of atomic mass, we would find that potassium would end up in a group with helium, neon, krypton, and xenon. They are all gases and very unreactive. However, potassium is a very reactive metal and does not fit with the chemical properties of that group. Similarly, argon is a very unreactive gas, and if swapped places with potassium, would end up in the same group as lithium, sodium, rubidium, and cesium, and it would not fit the chemical properties of that group. Dmitry Mendeleev was a Russian chemist who worked throughout his lifetime on developing and improving early periodic tables to make it look more like the one we know today. His key changes were that he did not always follow the order of atomic weight like the early periodic tables did. Sometimes, if elements did not suit the pattern or the chemical properties of their group, he changed their order. He ensured that all elements were grouped by their chemical properties. He also left gaps for undiscovered elements. For example, this question mark here with the number 68, this element soon became gallium, and this element with a mass number of 72 became germanium. So let's see what you know with a true or false quiz. Question 1. The modern day periodic table is an order of atomic mass. That's false. It's atomic or proton number. Question 2. The modern periodic table has groups of elements with similar chemical properties. That's true. They are. Question 3. Earlier periodic tables were in order of atomic mass. It's in fact false, and we've got to be careful here. It was called atomic weight, not atomic mass. Question 4. Mendeleev always ordered the periodic table by atomic weight. That was false. He changed the order if the element did not fit the properties in their group. Question 5. Mendeleev left gaps for undiscovered elements. Yep, that's right, that's true. He did. The next lesson in this unit is Lesson 8, Isotopes. Thank you for listening to the GCSE Science Tutor. Please remember to like and subscribe to get further updates on lessons and tutorials.